importance of the course importantly. Then I will go in detail about the course contents. Okay, that is syllabus, and what are the textbooks to be referred, and what is our plan in executing this course content. Okay, so yes, are you able to hear me, ma? Anup,
Yes, sir.
Yes,
Anupam
sir.
is there?
Yes, sir.
Yes. So, right. Is that? Next slide change. Banis?
Yes, sir. ಇಲ್ಲ ಯಾರು ಡೌನ್
ಅದ ಇದು ಮಾಡಿದೆ ಬರ್ತಾರೆ ಅಲ್ಲೂ ಮಾಡಿದೆ
ಪಿನ್ ಮಾಡಿ
ಅನ್ಪಿನ್ ಅಂತಿದೆ
ಇಲ್ಲ ಬಿಡ್ತಾರೆ ಸರ್
ಸ್ಕ್ರೀನ್ ಐತಿ ಅಂತ ಅವ್ರಿಗೆ ಕಾಣಿಸುತ್ತೆ ಬಟ್ ಚೇಂಜ್ ಆಗೋದು. Yes, are you able to see the slide changed?
Yes, sir.
What is
Yes,
the
sir.
slide? What is that?
So vision and mission of the
Okay,
department.
good. Yeah. So now it is changing. Yeah. So to begin with, let me discuss what is vision and mission of the department. With this following vision, department is working at institute. Okay, vision of electronics and telecommunication engineering department is to emerge as a premier department developing high quality electronics and telecommunication engineering professionals with ethics, eco-friendliness for the betterment of society. This is our vision, our department vision, and in this direction we are putting our efforts. Okay, to realize this vision we are putting our efforts. That is how we are able to achieve is a mission statement, and you will see here the different 3 statements what we have defined here. So to impart quality education just by telling in word is not possible, so we have to create a conducive environment, learning environment and research attitude in both faculty as well as students, right? Then only it is possible to realize our vision. So first statement is conducive learning environment creation and research activities that we have to involve in. So we need to develop a good communication skills in order to discuss, deliberate the technical aspects in engineering. Okay, within ourselves, within our technical community, and even with outside world, right? So you need to have you need to build leadership qualities and ethics among the engineering graduates. Strong industry institute interaction, this is also one mission statement in order to get the support from the industry in order to upgrade ourselves and be industry ready. So keeping this vision and mission in mind, we are working and to to achieve our OBE, outcome based education, and its importance. I'll be talking in brief on this also. So practicing OBE and its benefits, few points I have highlighted here. So department is practicing OBE, that is outcome based education practices you have, and these practices are defined by NBA Washington Accord. Okay, so every curriculum will have objectives and outcomes. So what is a motto behind this? Every graduate coming out of this institute or department will be able to achieve some attributes defined by NBA. Okay, so those attributes I will discuss later, but one or two just to tell you what it is. See, at the end of the course means electronics and telecommunication course, you will be able to apply the fundamental knowledge of science and engineering in solving the engineering problems. Okay, so you'll be able to apply. That is a meaning. See, outcome, that is program outcomes, what we call program. What I'm talking is electronics and telecommunication engineering program, or a stream, or it is a department what we are talking. Okay, so engineering graduates from our department, they should be able to apply their engineering, yes, knowledge in solving engineering and basic science knowledge uh, in solving the societal problems. That is the first program outcomes tells. Okay, so these are the attributes what I'm talking. Like this, you have 12 attributes. Second one is analysis level. If you are studying something, some circuit based subject, if you are able to hmm? Hmm? Huh. So yes, so that's what the program outcome. Second one is analysis, third one is design, so fourth one is conduct experimentation, investigations, fifth one is usage of modern tools, whether we are upgrading ourselves in building and realizing the problems, or to solve the problems, how we are able to no implement the things in reality, how we are making use of the existing modern tools in our course, that is concept analysis. Okay, then what is the impact of engineering solutions to the society? Yes, what ethics, how we exhibit ethics as engineers in our daily practices, right? So what is no effort made in make you no effective communicator. And then finally, project financement, how we incorporate, or how we train graduates in taking care or understand the importance of this project and finance in their regular work culture, right? Finally, self study or continuous learning is one more attribute of an graduates. So like this, 12 graduate attributes have been defined, and we are trying to incorporate, we are trying to train student in this direction, to build this attributes in a student. We are trying our best. So these are the these are the program outcomes, and we have some benefits. Why we are talking about outcome based education? Because it has got benefits for both students and as well as organization, right? So this OBE practice will give clarity. What is a clarity? What student will be able to do at the end of the course? What is the expected? What is the expectation from a student at the end of the course? That is at the end of 8th semester I'm talking. End of the course means it is at the end of 8th semester, what you will be able to do. Okay, what is the expected? What is that expected from you? Okay, so it is a clear expectation of what needs to be accomplished by the end of the course. That is a clarity you will have. You will have an objective to study the subject, and what is to be achieved out of it. Okay, so next is you have flexibility in OB practice with clear sense of what need to be accomplished. Faculty who is teaching the course will be able to structure the curriculum or the syllabus around the students' needs. Right? Comparison is no, that gives how you are different from other institute, other graduates, or a graduate from other institutes. That is how you can have a comparative analysis with you, how you are different from other graduates, or this institute different from other institutes. Okay, so involvement, student involvement is the key in no OBE practice. OBE, when we are saying we are practicing OBE, student involvement is a key factor in it. Students are expected to do their own learning. Even you have seen in our regular question papers, we have case study questions where we are giving a material. Maybe some teachers, course coordinator may give you a paper, right? So that paper you have to read and understand your own, and then you should be able to write in the exam. That is what self learning. You are reading the material and you are able to understand and apply it, right? That is what the self learning is all about, right? So I will be giving some self learning task later part of this course, but yes. Students, are you able to see the new slide here?
Yes,
Yes,
sir.
sir.
Yes,
What is the
sir.
slide, ma'am?
Power electronics system.
Yes, yes, good. Yeah. So we understood some of the OBE practices and its benefits. You'll have, a student will have a better no, learning outcome at the end of the course. That is what in one sentence I can say about OBE. So what subject I am teaching is power electronics and instrumentation, but almost 4 modules you have power electronics, 3.5 exactly speaking. It is more than that. So 1.5 module you will have on instrumentation. So focus will be on power electronics, and at the end, last module I will be dealing more on instrumentation part, instrumentation devices, instrumentation circuits, instruments what we are using in the laboratory. So about that, it is there. So we'll discuss that along with the laboratory equipments, so that you will have better understanding of the module, that is 5th module and half of the 4th module. So first part, 3.5 module is power electronics. So I will be concentrating more here in the beginning. So power electronics means what? Power electronics is a field of electrical engineering that deals with application of power semiconductor devices for what? For control and conversion operation. That is, it is a study of electrical and electronics engineering which deals with the power conversion and control. In simple words, if you want to define what is power electronics, you can say it is a power conversion, it is a study of power conversion and control. So power conversion, see, power from the power station, what supply you are getting? 230 volts, 50 hertz supply, AC you are getting, right? Hope you all know this. Whatever you are getting power from the power station to your homes, in your office, college, whatever, if you plug in the devices, you connect to power supply, what supply you are getting? It is 230 volts AC, which is having 50 hertz frequency. Hope you understand this point. So energy may be, power may be in any form. Maybe it is AC power, maybe DC power. Okay. So suppose say you are traveling in a train, and you need to turn on fans and bulbs. That power you are getting from the batteries, right? So you have a DC power stored in the batteries, and on that DC battery your fans are running. But here in our homes and offices, our fans are running on AC, correct? No? So power may be in the form of AC or it may be in the form of DC. So but what you want in traction application, in trains, you need a DC power, because you connect a wire to, you know, fans in the trains, right? Here in the house you can directly take wired line connectivity you can establish with your devices or your fans or bulbs. Hope you understand this point. So power may be in any form. Suppose say you are developing a power system, power supply unit for satellite. So you need to have a battery which is capable of, no, storing more power in a small space, right? So you have different techniques, different battery techniques, battery no you will have DC power it is. If you want AC also, you need to have again circuit which can convert DC into AC, because there in satellite instrument you will not have, you know, AC available. So you have to convert existing DC stored in the battery to AC if there is a AC requirement in the application. So something like this, what power you have and what power you need. Actually availability maybe in AC, but you need a DC, so there is a need of conversion from AC to DC. Simple. So that's why first block, this block, what it is showing, power electronics converter. Converter may be AC to DC converter, it may be AC to AC converter, it may be DC to DC converter, it may be DC to AC converter. Hope you understand what is AC and DC. You have studied basic electronics, basic electrical engineering in the first year. I will not stress. Later in the syllabus I'll go in detail, but in the beginning this block diagram I have taken just to convey what is meant by power electronics. Simple as that. Okay, so power electronics is a subject which deals with power conversion and control. So I'm talking about power conversion here. Circuitry, what block I have shown here, power electronics converter. Okay, if you have AC input and if you need DC at the output, you use AC to DC converter. Simple. Okay, and how you are controlling that? What is the intelligence you have built? You have a controller at the bottom block, you can see. Controller block will give the commands or the pulses to control the devices, power devices in the converter block. Okay, that is how you are able to get the controlled conversion at the output. So that is what the meaning, power conversion and controlling is happening in this block. So this defines what is meant by power electronics. So load may be your fan, your tube, yes, bulb, or any machine that you are running. So load may be anything. So most of the cases load may be RL load, R load, and RLC. Okay, so if it is a motor, you are connecting fan motor, it will have RLC. Okay, and with the back EMF. So load will vary, and depending on the load, the analysis should be done in reality, and you should be able to, you know, improve the performance of this power converters, and, you know, and that is how you can contribute into this domain. So this is about power electronics meaning and why we are doing this, because it has got plenty of application in reality. Yes, are you able to see application of power electronics?
Yes, sir.
Yes, good. Yeah, this application, you just check the list of application. It has got automotive traction on the top, what I have written, subways, hybrid electrical vehicles. People are talking today. Yes, in abroad, abroad many electrical vehicles you will find on the roads. In India, you have very few vehicles, okay, on the road, and but in the future you can expect more and more electrical vehicles on the road, because you have challenges. People are working on, these challenges and within few years you will be able to see more and more electrical vehicles on the road. So that detailed discussion I can do on another day when I come to DC to DC converter and inverter. When I discuss with application, I will be able to talk on this electrical vehicle also, because application we should know for the course, for the subject. Then only you will understand the importance. Why we are studying this subject, you will understand. First, you have to understand the importance and application. Why should be the question. Why I am studying this subject? Because this has got plenty of application what I have shown here. Yes, so electronics engineer, electrical engineer has a big role to play in improvising the performance of these power converters, circuits, and control techniques. That is electronics part, intelligence part. Electronics engineer can play a big role in making a system work efficiently, okay, effectively, with a faster pace. Okay, so that is how you have plenty of room to improvise upon the existing system, right? So that is about the application of power electronics into electrical vehicles. You have many application in process industries, maybe paper mills, maybe cement industries. You have many mills, rolling mills, okay, construction machinery you have, where you need to run the motors, right, without producing much noise. So you need to have a better power electronics device for the switching action and the motors to control effectively, to meet the requirements of the application. So you have wind system, again you have a motor controlling mechanism there, you have power motors there, and to control the motor effectively you have electronics controlling unit that plays very important role. Renewable energy, it is mostly solar system, solar energy. People are talking, a lot of research is going on, and no um, you are making use of solar energy, and you are charging batteries, and you are applying to many applications, right? So a lot of scope in improvising the existing system to uh, uh, give the better performance in reality. Okay, so you have seen you will find many application in no of this power electronics in defense and aerospace, satellites, right? So aircrafts, right? You have smart grids, people are talking about smart grids, right? HVDC, it is transmission system, high voltage DC transmission. Okay, you have UPS systems where you are using inverter. You have computer where you have power supply is coming from you, that is SMPS power supply unit you have in CPU. If you see the computer in CPU part, you will find SMPS power unit, right? So that is also application of a power electronics. That power module is that is a requirement of your computer, switched mode power supply units. So that also I will discuss in brief in later part of this course. Okay, you have vacuum cleaners, you have electrical power steering, modern traction system, what I was talking in the beginning, right? So all these areas you will find applications for this power electronics. That much importance this power electronics has gained, and this has a big impact on the economy of any country. So if you study the different nations economy, power electronics plays important role. Electronics and power electronics, they go hand in hand, because controlling is from electronics, and power converter, power devices, power no, drive control applications, you will find power and signal. When I'm talking, I hope you will understand power. When I say power level electronics, it is electronics which you are dealing at a higher power and higher voltage, higher current level. So in signal level electronics, what we talk, electronics people, majorly electronics and telecommunication, majorly we talk only signal level electronics. Means if you are trying to design an amplifier, you deal with the power supply only around 10 to 12 volts or maximum 15 volts. Okay, so in most of the application you limit your power supply uh, range, okay, to 12 or maximum 18 volts, 24 volts maximum, I can say, not more than that. But if you are operating some motor at 230 volts, it is a power electronics you are talking. You high power, high voltage and high current applications you are talking, right? So what is the difference, how a device will be able to withstand high power? Some devices are not capable of handling high power. They are used for low power application, low power, low, that is signal, what you say, signal level electronics. So you should be able to differentiate. Once I cover power semiconductor devices in the first module, okay, I will discuss on that in detail. Then you will have a clarity, what is the role of no electrical engineer, what is the role of electronics engineer, and what are the power devices, what are the signal level electronics devices. Okay, you will understand um, better. Okay, so this is a small the scenario energy scenario in no global markets. What you find in 21st century, this power electronics has gained enough maturity with several decades of progress done in this device fabrication, that is power semiconductor device I am talking, in converter circuits. Lot of invention, lot of improvements people have been achieved, and with the result of that, today they are able to reduce the power consumption in the system, that is power conversion part, and they are able to improve the efficiency of the system. And this has got a big impact on the economy. You can save the energy and you can improve the performance of the system, and hence it will have a big impact on the economy as well, right? So it includes even pulse width modulation techniques. I will talk about that, you will not understand at this stage. So electrical machines, electrical motor drives, advanced control system, and simulation techniques. In this area, a lot of invention have been taken place, and that's how people are able to improve upon the system performance, right? So with this this one, some survey in USA says, electric power research institute in US, they have roughly estimated that 70% of the electrical energy that flows through power electronics will eventually grow up to 100%. That is their prediction. In the 21st century, we can see tremendous impact of power electronics, not only in global market, but also in the energy sectors of every nation. Okay, so how you are able to save the energy, how you are able to make use of renewable energy in a more uh, that is with in better way, and then how you are able to bring or develop hybrid vehicles in near future. Okay, so that depends on the progress that we achieve, the contribution that electronics and power electronics engineers contribute. Yes, so it depends on that. That is a scenario. At the end, again, I will tell the importance of this course with now what are the companies that are working on this, and which will affect the global economy. Okay, so to study this power electronics course, I have defined some objectives at your level, third sem level, just to understand the fundamentals better, working principle of power devices. Based on that, I have defined one objectives: understand the working principle of power devices, and at the end you will be dealing with measuring instruments as well. So you'll be studying and analyzing different power device based circuitries and different turn on and turn off techniques, that is triggering uh, techniques we call. So major device what we'll be dealing is thyristor, is a family of devices, no doubt. But when you say SCR, silicon controlled rectifier, I think somewhere you have studied this in the basic electronics, the SCR, thyristor, you have studied its characteristics, so it will be easy. In the first module, I will be repeating the same, so it will be easy for you. It is just a repetition, but I will be going in a little detailed uh, aspect of it. Okay, so majorly will be concentrating on thyristor device, so it is very easy, right, to know deal with different circuits based on the thyristor devices. So you should be able to know solve problems with respect to power electronic circuits, maybe in conversion part, power conversion and controlling. Small simple application will try to evaluate. Simple application will try to build and then evaluate the performance of those converter circuitry at the end. And I'll be giving this part for assignment, that is tool based assignment. There I'll be expecting you to exhibit this. Okay, learn the application of power electronics, power devices in control rectifiers, converters and inverters. So these are the simple objectives I have defined. At third sum level, these are the objectives. Okay, we can concentrate and we try to achieve the outcomes expected. At the end, I will be dealing with outcomes also, what is expected at the end of the course from a student. Okay, so another 10 minutes I'll discuss on the syllabus. With this objectives, we discuss the syllabus in this power electronics course. Module 1 deals with introduction of this power electronics devices and circuits, for this power devices and circuits. And brief history will discuss what is the evolution, what is the progress we have achieved, how what the devices you had in the beginning of this power electronics invention. In the beginning, what devices you had and what is the progress done till today. Okay, I'll be discussing on that history part. And then again, what is power electronic system, power converters and application, I'll be discussing in detail. Right, so part of this module, you have main device called thyristor, as I said already, thyristor or SCR. So before applying that device in the converter circuit, first we have to understand what is the characteristics, what are the characteristics of this device, how it behaves. Okay, and how to turn on and turn off this device, so that majorly we are using it as a switching device. So that is important, because in power conversion converter circuits, switching action is important. How fast you will be able to achieve switching of a device, and how effectively you will do that, how you will be able to reduce the power consumption or and improve the performance, that counts. So understanding fundamentals, that is characteristics of the device, is very very important. So some turn off methods also you will be discussing, as this device once turned on, difficult to turn off when there is DC power. Okay, AC power during negative half cycle you can turn it off easily, but turning off with the DC supply, there is a challenge. So turn off methods are also important in this discussion. So you have some triggering circuit discussion, as you have seen in the basic electronics. Pulse triggering, usually you preferred resistive, and you discussed about firing circuits in brief. I'll be talking on the same, but with some examples and some problems will solve, numerical problems will solve, so that you will have better understanding of the concept. Next, finally, in this first module, you have unijunction transistor. That is very much required when you want to turn on the SCR or thyristor smoothly. No, uh, uh, that is to avoid the fails triggering. Usually this UJT is preferred in order to turn on device with the precision. Okay, so UJT role in turning on SCR. Keeping that application in mind, I'll discuss in this module. So module 2, I'll not go in detail because another 10 minutes, 5 to 10 minutes. After that, we can have a discussion for 5 minutes, 10 minutes. 5 minutes I'll discuss on the syllabus. Yes, second module you have converter, phase controlled converter. That is, you are talking about AC to DC converters. You have studied rectifiers. Rectifiers are also called converters. They are converting from AC to DC only. But how these power device based converters work and what is the importance of this? Okay, here you have controlled operation and controlled output you will be able to achieve. But in rectifiers, you will not have control over the output for the that is 0 to pi and pi to 2 pi. In between, you will not have any control over the output, that is waveform, right? So that controlling at the output is possible with power device SCR here. That complete circuit analysis will be dealing here. Okay, so with waveform and mathematical analysis, power efficiency and all we have to discuss here. Okay, again with the different load conditions. What are the load condition I'm talking? Resistive load and inductive load majorly I will be discussing. Okay, so as I said, fan will have inductive load, right? Because there is an inductor coil which will have inductance. When you say inductance, definitely it will have resistance, no doubt, but we call it as an inductive load. Okay, only resistance, it is a resistive load, right? Similarly, we will discuss choppers. Choppers are the circuits which convert DC to DC, fixed DC to variable DC. That is a meaning. The meaning of chopper is converting fixed DC to variable DC, and you will have a different classification of these choppers and applications of this in different areas. That also I will focus. Okay, third one, module 3, it will deal with inverters, its classification again with the different load conditions. And part of module 3 is switched mode power supplies. Switched mode power supplies, as I said, this is a power supply unit you will find in your computer CPUs, right? Computer gets power supply from this SMPS, and that SMPS module is there in what? CPU backside, if you see. Okay, so that circuit circuit will be discussing in detail, and then some measurement instruments, errors and all will discuss at the end of this module. So module 4 is digital voltmeter, digital multimeter will be discussing, and these multimeter, voltmeter and all will be using in the laboratory, and that same equipments, same instruments will be studying theoretically in this course. So you'll have better understanding about the equipments that we are using in the laboratory. Okay, so in the module 5, it is more of transducers and sensor topics you will be discussing, and different types of transducers, resistive transducer, you have many, and again at the end we will talk about thermistor, LVDT. Okay, and then instrumentation amplifiers at the end, Instrumentation amplifier has got many application in the processing industries, and you will find you will see different circuit I'll be discussing here. And finally, programmable logic controllers, PLCs we call. Electrical people will have this one course on PLCs. Okay, very important controller unit used in processing industries. Okay, this works on the switch logic. Okay, relay logic. I'll discuss in detail at the end of this course. So these are the textbook you can go through. First textbook, what is prescribed is MD Singh and Kanchandani. Power electronics is a subject. Second edition, you can go through this. Otherwise, you can refer Muhammad Rasid, which is a standard book again, prescribed in most of the universities. Many universities, this is a prescribed book. In the reference, first book, what I have mentioned, Muhammad Rasid. Power Electronics, Circuits, Devices and Application by Muhammad Rashid. Okay, so third or fourth edition you can refer. Then no, Umananda you have. Umananda author has written Power Electronics. That is also good book. David Bell you have. Elprick and Cooper you have. Okay, for instrumentation part. Instrumentation part, one book is Kalsi. And the first part you will see HS Kalsi, electronics instrumentation. Okay, so these are the books you will be referring, but to be specific and not to get exact material required for your course, you will you can refer MD Singh for Power Electronics and Muhammad Rasid. Okay, I'll be referring these two books, and I'll be giving you notes, PPTs, some videos relevant to this concepts and application of these this power electronics course. So this is about today's lecture. I discussed in brief what is power electronics, importance of power electronics, its impact on the society, how other countries are working on this no to improve the performance, what are the research aspects I will talk later. But to understand this subject in a better way, just let me come to this power electronics market categorization. The global market power electronics is categorized into different types, mainly on the following categories. One is type of power electronic circuitry, or the module that you will be using, and material used in developing these devices, power devices, and what is the voltage level, whether it is medium, high or low. Based on that also you will have a classification. Okay, and end user perspective also, based on the end users usage also, the classification is done. So based on the type, market is segmented into power ICs, power modules and power discrete modules. Okay, in terms of material, market is classified into sapphire, gallium nitride, silicon carbide, silicon and other materials people are using to develop power devices, so that they can make compact power devices, and which can give better performance and less create less noise or hormones in the circuitries. So people are doing a lot of research in gallium nitride material, silicon carbide, and that they have got good result. They are able to achieve good results, and future your electrical vehicles and many defense application will get impacted by these researches. Okay, with respect to voltage, this market, power electronics market, is grouped into medium, high and low voltage, and ending user segment is classified into military and commercial. So this is a market categorization of power electronics. These are the important companies, major companies that are contributing, and they are the driving force for this power electronics market. So one being analog devices. In the USA, they have fab labs. They are developing power devices and power converters, majorly required for this defense application and even for electrical vehicles. Keeping all this in mind, people are developing the power devices. Okay, on semiconductor corporation, again in USA, they are also working, and they have already released a few products related to defense and vehicles. Renesas Electronics Corporation in Japan is also involved in developing power converters and control unit. Micro Semi Corporation, Texas Instruments, NXP Semiconductors, Netherlands. They are also working on this power electronics module development control units. Um, and TT Electronics UK. Again, you have Mitsubishi Electric Corporation in Japan, ST Microelectronics in Switzerland, Infineon Technology, you know it, in Germany. They are also involved in this power electronics market. They have also contributed much. Collins Aerospace, you have in US, which is also contributing largely into aircraft units and power electronics required for aircrafts and aerospace applications. So like this, you have many companies working or driving this power electronics market. So most of these companies operating in the market for power electronics are focusing mainly on generating more revenue by engaging with the defense units and military sectors of various nations. They have collaborated with the different country people, and they are delivering power units for these defense and military sectors. USA is increasing investment in military upgradation programs, especially advanced military weapons. They are emphasizing this, and they are developing equipments, weapons based on this power electronics. So circuits and okay, they are able to demonstrate the usage of this power electronics, and they are able to tell that this will have a big impact on the economy of the country. Okay, so this is importance of this course. So I'll stop here. Course outcome I'll discuss in detail in the next class, along with this course content what we discussed today. So let me know if you have any questions in 2-3 minutes. Yes, dear students, do you have any question, any queries? Feel free to ask me. Anupam?
Yes, sir.
Naivedya? Sanjana?
Yes, sir.
Any queries?
No, sir.
Not right now, sir.
Are you able to follow something? Are you able to understand what is the importance of this course? Are you able to understand
Yes,
the
yes.
objectives of this course?
Yes, sir.
Yes, sir.
Okay, good. So what about others? You should be, interactive. You should be asking questions. Okay, you need to ask questions at the end of the class. In between also, you can interrupt me. Okay, if you have not followed anything, please feel free to raise your questions. Okay, so because this is a subject where you have plenty of analysis, circuit analysis. Okay, it is not a theory subject. You will have power devices in the beginning. First module you will discuss. Along with that, you will start discussing different circuitries based on these power devices, and then circuit analysis, waveforms. You should be able to write, and a mathematical expression for few circuits. At least at third sum level we have to explore, even if it is Yes, some chapters he has given no derivation based approach. Some chapters he has not given in the syllabus, but wherever it is required, very much required, we have to analyze the circuit mathematically. We should be able to write the waveforms. Okay, if you understand the working of the circuit, definitely you will be able to write the waveforms. If you are able to write the waveform, you can derive any expression, power efficiency expression and all. Okay, so analysis, this course needs analysis. You cannot simply remember and no write the exam. That's why I want you to concentrate from the beginning. Okay, so I'll stop here. If you don't have queries, I'll close the session. Thank you. Anything from anybody? Any query? Please feel free. I will wait one more minute. Yes, Anupam is there?
Yes, sir. Yes, sir.
Anupam, you just no. Give me the list of students attended. I have some, but I will recheck again with your list. Okay, will you be able to give me maybe by
Okay.
evening?
Okay.
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 Yes,
Okay.
yes.
Yeah. Yeah.
Okay, done. Okay then.
So for instrumentation, you suggested only one book, right? No, sir.
Kalsi is a standard book, ma. You can
Okay.
refer that. One more book, no, I will tell you. Okay, but Kalsi is a standard book for instrumentation.
Okay.
Last part. Okay, rest
Okay, sir.
is no 3.5 module is power electronics only. Okay,
Yes, sir. Thank you, sir.
last module. If you want, I will give notes also. Not an issue. Kalsi. Along with that, you can refer Kalsi.